Today we are going to explore the red supergiant star Betelgeuse, which is located in the Orion constellation. In recent years, the star has started to dim substantially, causing excitement and fear around the world. Some believe that this dimming was a sign that the star was about to erupt and become a supernova. However, so far, Betelgeuse has not exploded. Although it is nearing the end of its lifespan, Betelgeuse is transitioning back to a less active condition. This is a relief for many scientists who were concerned about the possibility of a major explosion that could affect Earth. Betelgeuse is the brightest and largest star in the Orion constellation and is officially known as Beta Orionis. It physically erupted in 2019, creating a massive surface mass ejection and losing a significant portion of its visible surface. This behavior has never been observed in a star before, and the coronal mass ejection that frequently occurs in our Sun is insignificant in comparison. The cloud of hot gas that the star released, temporarily covering some of the star's light rays, was what produced the strange dimming of Betelgeuse. Determining the distance of red supergiant stars like Betelgeuse is a challenging matter in astronomy. Some estimates place Betelgeuse at a distance of up to 724 light-years from Earth, although this is still difficult to confirm. In summary, although Betelgeuse is nearing the end of its lifespan, it is still unclear whether the star will explode into a supernova. Scientists continue to monitor the star and study its behavior to better understand its future. Betelgeuse is one of the brightest stars in the sky due to its inherent luminosity, being about 100,000 times brighter than the Sun. However, such brightness comes at a cost as the star soon depletes its fuel, hastening the end of its existence. Eventually, it will run out of fuel and collapse under its own weight, as its primary nuclear fuels have been exhausted. If our current hypotheses are correct, it will erupt as a supernova and eventually become a neutron star or, more likely, a black hole. But is Earth in danger because of Betelgeuse? Undoubtedly, a supernova explosion occurring within a few tens of light-years from Earth would have the worst effects. When a supernova explodes, it can produce light equivalent to an entire galaxy. Therefore, if one of our nearby neighbors, such as Alpha Centauri, were to act in this way, we couldn't ignore it. It wouldn't matter if Betelgeuse shone as brightly as the Moon, as it would be bathing us in radiation of all kinds. However, since 1604, we have not observed a supernova in our galaxy. In 1987, a supernova erupted in the Large Magellanic Cloud, with effects that were clearly discernible even at a distance of 169,000 light-years. Although there was no risk, it is fortunate that the Large Magellanic Cloud is so far from the danger zone. Around a typical supernova, it is an interesting concept to work with what would happen if a supernova were to explode. Nearby supernovae are not the biggest explosions in the universe and seem almost insignificant compared to gamma-ray bursts. But that is a very different thing. Supernovae are bad news as they have the power to destroy biospheres and cover worlds with lethal radiation, destroying the ozone. According to a recent study, a layer of a planet can be destroyed by a particular type of supernova years after the explosion, which adds a new potential danger. Giant stars can briefly reach some of the highest luminosities in the universe when they explode in massive explosions known as supernovae. The brightness of hundreds of billions of stars combined can be eclipsed by a single supernova. It is said that Earth will be destroyed by a Betelgeuse supernova, the star that will be the second brightest object in our sky after the Sun when it explodes. Despite being light-years away, Betelgeuse, which shines brighter than a full moon, will be visible during the day and will be so dazzling for a few days that shadows will be cast even in the midst of darkness. Despite its terrifying brightness, only the visible light emission from the supernova makes up a very small amount of its total energy output. Furthermore, while exposure to high levels of visible light can result in blindness, it generally doesn't have many other harmful effects. The impact comes from the high-energy radiation associated with the supernova, which typically takes the form of X-rays and gamma rays, and is more concerning. High-energy radiation has the ability to catalyze oxygen, depleting the ozone layer that protects the Earth. Without ozone, life on the Earth's surface would be subjected to the full force of the sun and ultraviolet radiation, which can result in an extinction event within the first few seconds of a supernova. An explosion of radiation occurs, but a greater threat emerges later, eventually hundreds or millions of years later. Cosmic rays, which are subatomic particles accelerated to nearly the speed of light, burst forth from the maelstrom. They can also destroy ozone layers and blanket a planet's surface with deadly radiation, in addition to carrying a considerable portion of the supernova's total energy. Recently, it has been discovered that the presence of iron-60 in lunar cores, regolith, and deep-sea sediments may indicate that the Earth has been struck by a supernova ejecta in the past few million years. While there are no nearby supernova candidates that could threaten life on Earth based on the dangers of gamma and cosmic rays, astronomers have identified a new potential risk. A specific type of supernova has the potential to emit additional and far-reaching lethal radiation that can be dangerous for worlds like Earth. When a star nears the end of its life and is surrounded by a substantial disk of material, a specific class of supernova can arise. After the initial supernova explosion, a shockwave strikes the disk, causing it to become extremely hot. This leads the disk to generate a lot of X-ray radiation, which has a high energy density and a long travel range. The brightest supernovae can destroy up to 50% of a planet's ozone layer, which is more than enough to cause an extinction event at a surprising distance of 150 light-years. These supernovae could be a lethal blow to a fragile planet, bombarded by X-rays months or years after the initial explosion. Cosmic rays would then arrive hundreds or thousands of years later and complete the task before the biosphere had time to recover and replenish its shield. Fortunately, no X-ray supernova candidates have been found near Earth, but the galactic habitable zone is now subject to constraints as a result of this research. Star formation is insufficient in regions farther from a galaxy's core to produce the necessary elements for generating rocky planets. However, dense star centers where they live and die rapidly are equally deadly because frequent supernovae irradiate the surrounding area. The inner boundary of the zone is likely located farther from the galaxy's core than previously thought. Earth was situated in one of the safer neighborhoods of the galaxy, despite occasional hits. The time when Betelgeuse will explode is probably not going to occur during our lifetimes, however, no one truly knows when it will happen. It could occur today or a million years from now. Betelgeuse's supernova explosion appears from Earth, and Earth's biosphere will not be affected, but that doesn't guarantee that no one will be warned. According to Goldberg and Bauer, Betelgeuse will remain bright for over 3 months after its explosion, shining with a brightness comparable to a half-moon, which is 9 times dimmer than a full moon. A single point would contain all that brightness, and as a result, it would appear as a very bright beacon in the sky that you can see during the day, casting shadows at night, which would be unavoidable. Everyone on the planet would be captivated by it. The supernova would be visible to people in the sky during the day for about a year, and as the supernova remnant fades, it would be visible to the human eye at night for several years. Orion will be missing its left shoulder for as long as it completely disappears. Although stellar explosion is not a major concern, the supernova could have some unexpected effects on Earth. For instance, many animals rely on the moon for navigation, and encountering artificial lights can be confusing and disruptive. Adding a second object that is as bright as the moon would not only disrupt wildlife, but also impact astronomical observations. Studying Betelgeuse is already challenging enough, and the intense light would damage astronomers' instruments. They claim that there would be plenty of warning if Betelgeuse defies the odds and explodes within our lifetimes. Earth's detection instruments would start picking up gravitational waves or neutrinos produced by the explosion up to a day in advance. Imagine a significant portion of the population staying up late to witness Betelgeuse's light show. I was looking forward to the moment when Betelgeuse, the red supergiant star, would be the subject of study for scientists. This star doesn't need to explode to be fascinating and fast. Its size and brightness make the study very straightforward. Astronomers find it fascinating to examine a star that is nearing the end of its existence in detail. The physics within Betelgeuse's inner structure is captivating and based on what scientists already know about the star and other similar stars. From this information, they have made their best prediction about what is happening now. The study indicates that Betelgeuse's brightness may be changing due to a variety of causes. Some astronomers even believe that multiple dimming mechanisms may be occurring simultaneously. When red supergiant stars near the end of their lives, they start to swell and form expanding envelopes of gas and dust, while their nuclear fuel runs out and the star's brightness increases as its envelope expands. However, a star like Betelgeuse can dim and brighten in other ways as well. Furthermore, red supergiant stars have vast convection cells on their surfaces, akin to much larger variations of those on our Sun. It's where hot material rises from the star's interior due to turbulence. Some of this material explosively bursts into space upon reaching the surface, creating a massive radioactive belch that can momentarily alter the object's brightness. Betelgeuse's dimming may even be a sign that it is about to explode. Generally, when material emerges from the surface of a dying star, it collides and causes the star to shine brighter. However, it's possible that this substance is enveloping the star, which would make it dimmer regardless of its underlying origin. Betelgeuse's peculiar behavior should ultimately reveal new insights into the demise of the red supergiant star. Everyone on Earth will be front-row witnesses to observe this moment. In conclusion, Betelgeuse will eventually erupt as a supernova, and when it does, it will be bright enough to be seen from Earth during the daytime.